Hello everyone, welcome back to our lesson. And today we are going to discuss lesson number 13. But of course, before we start, please make sure that you like and subscribe in my YouTube channel so that everyone will be happy. Alright, so this is a continuation of lesson number 12, and it is inequalities. So for the opening exercise, we'll be writing inequality statements. So it means we're going to be given a particular word problem, and we need to express that in a way that we're going to have inequalities and such. So for this one, of course, we have here Tariq is trying to save $265.49 to buy a new tablet. Right now, he has $40 and can save $38 a week from his allowance. Write and evaluate an expression to represent the amount of money saved after. So before we start, using the particular given weeks, what I want you guys to make sure is that we are going to create the expression first. So of course, 40 will be identified as a constant, so it means it won't change because Tariq already has it. So it means if he's not going to spend it, of course, we're not going to be able to change it. But based on the problem, of course, he's going to save money, so it's going to be a constant. And then we have $38 a week. So it means every single week or when the week passes by, he's going to get $38 each one of those week. So again, our target, make sure that you know it's $265.49. So if we're going to create that, we're going to have 40 plus 38. Let us use the W as a variable for the number of weeks. So for this one, we have 2 weeks. So what we're going to do, if you were given a particular number and it's already written in a way that the unit is the one that we are looking for, of course, we just need to substitute the given number to the W. So we got 40 plus 38 times 2. We're going to have 40 plus 76. So 40 plus 76 is 116. So as you can see, it is not possible because we are aiming for a 265. Next, let us try 3 weeks. So we got 40 plus 38 times 3. So we're going to write that. We got 40 plus 38 times 3 is 114. 40 plus 114 is 154, which is still not enough for the tablet. Next one, 4 weeks. We got 40 plus 38 times 4. So we're going to have 40 plus 152. Adding this will result to 192. We're almost there, so just a little bit more push. So we're going to have 5 weeks. Next is we have 40 plus 38 times 5. So 40 plus 38 times 5 is going to be 190. So 40 plus 90 is 230. Probably the next one is the one that we are looking for. So 40 plus 38 times 6. So we're going to have 40 plus 38 times 6 is 228. Adding that will result to 268. So we got the aim. All right. So basically, it should be at least 6 weeks. But just to continue our lesson for this one, just to continue in doing our work, let's just do this one. So we're going to have 40 plus 38, 38 times 7. So 40 plus 266. So 400 plus 266 is of course 306, which is already more than enough than what we are looking for. And of course we have 40 times 38. Oh, sorry, 40 plus 38 times 8, which is going to be 40 plus 304. So we're going to get 344. So it means basically, when will Tariq have enough money to buy the tablet? So as I said earlier, we were able to gain it 6 weeks. So we're going to write at least 6 weeks. Next one, write an inequality that will generalize the problem. So of course we have our original expression, which is 40 plus 38w. Okay, so at least the word at least means in the mathematical world is greater than or equal to 6, because it should be 6 and above. All right, so we have to make sure that we understand on how we generalize, or we have how we formulated the inequality given. All right, next one. The sum of two consecutive odd integers is more than negative 12. Write several true numerical inequality expression. So when we say again consecutive, it means it's continuous. It's going to be the next one after the other. So if we are talking about integers, it means it's going to be a positive and negative numbers, but we're just only pertaining to odd numbers. So it means we're going to mainly focus on 1, 3, 5, 7, 9, 11, so on and so forth. And of course, they're negative. They're opposites, which is their negatives. So for this one, we need to find two consecutive odd integers. So what do we mean by consecutive? Let's say 1 and 3. 1 and 3 are consecutive. 3 and 5, they are consecutive. 5 and 7, they are consecutive. But if I ask you, is 1 and 9 consecutive? Or 1 and 11, are they consecutive? Of course, they are not. It means they cannot be too much farther from each other. All right. So we got this. Of course, it should be more than negative 12. So let's try 1 and 3. So 1 plus 3, is it greater than negative 12? Yes. How about 3 plus 5? Is greater than negative 12. So basically, because it's more than all positive values, all right? So all positive consecutive odd integers is, of course, applicable. But let's look at the negatives. We got negative 1 plus negative 3, that is greater than negative 12, which in this one will be a negative 4, which still is okay. So next is negative 3 plus negative 5, of course. We're going to have a negative 8 here, which is still greater than negative 12. But when it comes to negative 5 plus negative 7, as you can see, negative 5 plus negative 7 will be a negative 12, wherein it is not possible already. So it means we're going to stop from there, and we cannot move on from our number. So now, it says here, the sum of two consecutive odd integers is more than negative 12. What is the smallest value that will make this true? Write an inequality that can be used to find the smallest value that will make the statement true. So we're going to create this. So to ensure that the integer will be odd and not even, the first odd integer is 1 unit greater than or less than an even integer. So it means, let's say you were given an x. So this is the integer. Okay, so if x is an integer, then 2x will ensure an even integer. All right. And then, of course, because we are looking for an odd number, we're going to add 1. So 2x plus 1 would be an odd integer, since it's the one, it is 1 unit greater than an even number. So this is the first odd integer. And of course, to get another odd integer, we got 2x plus 3. So again, How did we get 2x? It is because we need to ensure that the integers will be odd and not even. The first odd integer is 1 unit greater or less than an even integer. So it means we need to get an even integer first before we can most definitely get an odd integer. So now creating an inequality that will make the statement true. All right. So it means we're going to add both of this. So we're going to have 2x plus 1 plus 2x plus 3. Of course, we are pertaining more than to negative 12, so greater than negative 12. But we are not yet done there. So we can combine 2x and 2x, wherein that will be 4x. 1 plus 1 plus positive 3 is a positive 4 is greater than negative 12. So that is our inequality. Next, letter B. Use if-then moves to solve the inequality written in part A. Identify where the zeros and ones were made using the if-then moves. So it means we basically need to use the if-then moves to get, those numbers that we need to have zeros and ones. Okay, so writing that, we're going to have 4x plus 4 is greater than negative 12. So for us to create the 0, we need to add negative 4 on both sides, or we can just basically remove, of course, by using subtraction property of equality. Oh, sorry. So we use SPE. So we're going to have 4x plus 0 is greater than negative 16. Whoop, there you are. That's the zeros that we're looking for. So now 4x plus 0 is going to be 4x is greater than negative 16. Now for us to get a 1, all right, what we're going to do is to get, or of course, multiply both sides by the reciprocal of 4. So 1/4, 1/4. So we can cancel that. All right. So of course, we're going to have 1x is greater than negative 4. Or basically, this is the one that we are looking for. So we can just rewrite it as x is greater than negative 4. All right. Make sure that it should be greater than negative 4. Now, how are we going to check? Let us see letter C. It says there, what is the smallest value that will make this true? So because we are, pertaining to a negative 4, should be greater than negative 4. So let's try the numbers negative 3, negative 4, and negative 5, just to ensure that, we are using the right, or we're basically knowing the right decisions. So we're making the right decision. So let's do this. So we got 4 times a negative 3 plus 4 is greater than negative 12. You might ask me, where did I get those numbers? Whoop. Look at the original inequality. So we're going to have negative 12 plus 4 is greater than negative 12. Negative 12 plus 4 is a negative 8. Is negative 8 greater than negative 12? Yes. Okay. Now let's try the negative 4. So 4 times a negative 4 plus 4 is greater than negative 12. 4 times negative 4 is negative 16 plus 4 is greater than negative 12. Negative 16 plus 4 is negative 12 is greater than negative 12. Is negative 12 greater than negative 12? No. But if it was a greater than or equal to a negative 12, of course, yes. But for this case, it's not. Next one. 4 times negative 5 plus 4 is greater than negative 12. So 4 times negative 5 is negative 20 plus 4 is greater than negative 12. We're going to have negative 16 is greater than negative 12, which is also a false. So basically, as you can see, because the limit is only greater than negative 4, wherein it should be negative 3, negative 2, negative 1, 0, 1, 2, 3, so on and so forth, of course, we will be using those numbers which are greater than negative 4. So you might also ask me, how about, let's say, you were given a particular decimal and you are not being asked to round off. Of course, you can use that as the smallest value. All right. Now, exercises. Number 1. It says here, Connor went to the county fair with $22.50 in his pocket. He bought a hot dog and drink for $3.75 and then wanted to spend the rest of his money on ride tickets, which cost 1.25 each. Write an inequality. So to answer letter A, it says here, write an inequality to represent the total spent where R is the number of tickets purchased. So it means we're going to use the variable R on this particular given problem. So it says here, of course, we have a limit of $22.50. That is our limit because that is the only money that Connor has for this particular day that he went to the county fair. And of course, he already bought a hot dog and a drink, which cost $3.75. And each ride costs $1.25, wherein that is linked to the given variable. So we're going to use 1.25 R. So it means the ride, or each ride plus the hot dog and the drink, should be equal to 22.50, but it says inequality. All right, we're talking about inequality. So it means because we are basically talking about we cannot exceed this particular amount, it should be less than or equal to 22.50. It should be the maximum. All right. So this is our inequality. Now, letter B. Connor wants to use this inequality to determine whether he can purchase 10 tickets. Use substitution to show whether he will have enough money. So we have 10 tickets and it says use substitution. So it means basically we got R as equal to 10. So we're going to have 1.25 R, which is going to be substituted as 10. Plus 3.75 is less than or equal to 22.50. So 1.25 times 10 is of course 12.50 plus 3.75 is less than or equal to 22.50. 12.50 plus 3.75 is going to be $16.25, which is of course 22.50. So it means yes, therefore, yes, Connor can buy or can purchase 10 tickets. All right. So we got that because it's less than 22.50, as you guys can see. Now it says here, what is the total maximum number of tickets he can buy based upon the given information? So we're going now to solve for the value of R, because for us to know that he will not exceed his limit, we're going to make sure that he will be able to buy enough ticket for the rides that he wants. So 1.25 R plus 3.75, we're of course going to use first subtraction property of equality by subtracting 3.75 on each side. Okay, now we can cancel that. Bring down 1.25 R is less than or equal to 22.50 minus 375 is going to be $18.75. Now we divide both sides by 125, by $1.25 or 1.25, whatever you want to name it. So therefore, R is going to be less than or equal to, as you can see, we preserved it because we didn't divide by a negative. Going to be 18.75 divided by 1.25 is 15. Therefore, Connor can only buy 15 or less ticket for the money he has. All right. Next one. It says here, write and solve an inequality statement to represent the following problem. On a particular airline, checked bags can weigh no more than 50 pounds. Sally packed 32 pounds of clothes and 5 identical gifts in a suitcase that weighs 8 pounds. Write an inequality to represent this situation. So for this one, let us look at this. It says here no more than 50 pounds. So it means 50 pounds is their maximum number of weight limit. So it means it should be less than or equal to 50 pounds. Now it says here Sally packed 32 pounds of clothes, wherein it's not going to change. It means that is the constant. Okay, and it says here 5 identical gifts in a suitcase that weighs 8 pounds. I think there's something missing here. It should actually be weighs a total of 8 pounds, because for me, myself, I would probably also be lost with this, having 8 pounds as like each one of the gifts. But for this one, 8 pounds is just actually the total weight of those 5 identical gifts. So it means we're just going to add that 8. So this one also is a constant. So we need to determine the number of identical gifts. So let's use G. All right. So now we're going to have 5G plus 8 plus 32 is less than or equal to 50. So, of course, let us combine like terms first. As you can see, based on the problem, that we need to combine 8 and 32 first. So 5G plus 40 is less than or equal to 50. Now, we can subtract both sides by 40 because that is the given amount or weight, which is 40. So we're going to subtract that using SPE, or subtraction property of inequality. We're going to have 5G is less than or equal to 50 minus 40 is 10. And now using DPE, or division property of equality, G is going to be less than or equal to 10 divided by 5 is 2. So we got the answer. So it means each gift, or each identical gift, should only weigh 2 or less, because we do not want to exceed on that particular number. So basically that's it. I hope that you were able to learn more and you were able to understand more than you are expected to. I hope that on the next lesson you will also pay attention and you will also watch the next video. Again, thank you so much and see you on the next video. Bye.